All right, we're going to start with an algebra review that is solving literal equations. So in physics, we are usually given equations that don't necessarily have many numbers in them, but they have a lot of variables, such as x, v, and m, and we might have constants such as g and pi, and sometimes r. When you're asked to solve a literal equation for a specific variable, that symbol or letter becomes known as the unknown. That's what we're looking for. Everything else is going to be a literal. A term is a combination of symbols that are separated by a plus sign or a minus sign. So as an example, the equation below, if we were to be solving for a, or a equals, the terms are going to be our delta x, our v naught t, and our 1/2 at squared. Since we're looking for a equals, our unknown is that a. So some tips as we work through this. One of the things you need to know is the subscript stays attached to the variable that it's with. You cannot separate them. If you have variables with different subscripts like v naught and v with no subscript and v final, those are not the same thing. They cannot be combined. They are different. We also have this little symbol called a delta. The triangle is a delta, and it always stays attached to the variable immediately to the right. This is called delta. Now, delta has a meaning. It is final minus initial. So, for example, delta x is the final x minus the initial x. If I have delta t, that would be final temperature minus initial temperature. It doesn't matter what this variable is, it's always final minus initial. A couple of quick exponent rules that we use a lot in physics. If you have a square root, that can be rewritten as x to the 1/2. The square root is the same as having the 2 here for the square root. So using the same rule, if we have a cubed root, this number here becomes the numerator in our exponent. So if you have a 5th root, it would be x to the 1/5. If you have 1 over x, that would be x to the -1. If you have 1 over x to the 5th, that's x to the -5. We do use these specific rules periodically, and so you should be aware of them. A couple of reminders, things that we see a lot as problems. Remember, whatever you do to one side of the equal sign, you must do to the other. That equal sign means that everything on one side is equal to everything on the other side. You can't just multiply one side by something and not the other. To maintain equality, whatever is done to one side, you must do to the other side of that equal sign. Another thing I see a lot is when you're manipulating the literal equation, if the exponent is not part of your unknown, if it is not part of the unknown, leave it alone. You only undo an exponent if it is part of the unknown. We'll do a couple of examples that show that. Now, you can only cancel a variable or a constant if it is in every term on both sides of the equal sign. If one term does not have it, you cannot cancel it out. And again, we'll come to several situations where we're going to see that. Okay, quick reminder. Remember the order of operations, PEMDAS. It's the parentheses exponents, multiplication and division, addition and subtraction. Now, with physics, we don't usually have to do much simplification in the beginning. We're really just doing a lot of rearranging, which means in many ways we're doing sort of a reverse PEMDAS, which I'll show a little bit as we go through. So let's start with an example. Here are some quick steps that you can use to solve these equations. The first thing you always start with is, what is your goal? Your goal is always to get the equation in terms of your unknown is equal to stuff. So the first thing you want to do is you want to isolate the term containing the unknown. In this case, we're looking for a, so this is our term containing the unknown. So we want to isolate it by moving the v naught t. To do that, I'm going to subtract it from both sides. That means that the v naught t on the right side is going to cancel out. Now I'm going to rewrite my equation for the next step. So my next step is going to be isolate the unknown. In this case, I want to isolate the a, so I need to remove the 1/2 and the t squared. To do that, I'm going to multiply it by the reciprocal of 1/2, which is 2 over 1, and the reciprocal of t squared, which is 1 over t squared. Remember, what I do to one side, I must do to the other. So I'm going to do that to the other side. Now I'm going to cancel and rewrite the equation. So make sure that you have like these parentheses here, because whatever I do over here is going to be done to everything. So the 2 is not just going to be multiplied by the delta x. The 2 would be multiplied through to each term. So I have to keep it outside the parentheses and then divide by t squared. Now, this is a perfectly acceptable response. Me personally, since it's asking for a equals, I always like to flip it so that I have it in that terminology, which is the unknown is equal to, and this is my final answer. All right, let's do a couple of other practice. So this one, again, we are solving for a. So first we identify the term containing a, and then we are going to isolate the term containing the unknown, which means we need to move this. So it's being added to it, so I'm going to subtract it from both sides. And then I'm going to rewrite the equation. So I'm going to have my final velocity squared minus the initial velocity, and v is velocity, because these two cancel, is equal to 2a delta x. Now I need to isolate the unknown. So to do that, I am going to, you can either multiply by the reciprocal, which would be 1/2 times 1 over delta x, or you're just dividing both sides by 2 and delta x. And what I do to one side must be done to the other. These 2's cancel, these delta x's cancel, and I am left with my a over here. So to rewrite the equation, I have my final v squared is equal to, sorry about that, it's v sub f squared minus v naught squared divided by 2 delta x is equal to a. I could rewrite it in my preferred format, but either one of these would be an acceptable answer. There we go. All right, the next problem. This time we have what we're looking for, which is g, in the bottom underneath a radical. So this problem is a little bit more complicated. I can separate, well, using my sorry, had to pause for a moment. Once you get very familiar with doing these manipulations, there can be multiple pathways to follow. In order to keep consistent, let me rephrase how to do this. So for step 1, which is isolate the term containing the unknown, well, the term containing the unknown is already isolated. So I'm going to go to step 2, which is isolate the unknown, not the term, but the unknown itself. And there's this additional little step that says if the unknown is in the denominator, then multiply both sides by the unknown divided by 1. The problem is right now the unknown is underneath a radical along with what's on top. So somehow I do need to undo the radical so that I can follow this step. So this is a square root. So if I want to undo the square root, I need to do the square. I need to square the whole thing, not just part of it, all of it. So that means I'm going to have t sub p squared equals, and 2 squared is 4, pi squared. This whole thing is just going to become L over g. Now I can follow this step and I can multiply both sides by my unknown over 1. Here they cancel, and I have g t p squared is equal to 4 pi squared L. Now I need to continue with isolate the unknown and divide both sides by tp squared. And these cancel, and I have g is equal to 4 pi squared L over tp squared. And that is the final answer. All right, problem 3. This time we're going to be solving for this strange variable, which is a Greek variable that is pronounced mu, as in a kitten makes a sound like mew. So we want mu equal. You have to have this little tail in front to make the sign correctly. Well, this is our term that contains mu. Now normally that means that we would subtract this one from both sides, and we would end up with negative mu mg cosine theta is equal to negative mg sine theta. Rather than doing that and then multiplying through everything by negative 1, I can just take this term and add it to both sides, and I'm going to end up with both of them positive, and I am still going to have my term with my unknown isolated. Now I need to isolate my mu mg cosine theta, which means I am just going to divide by everything attached to it. This all cancels. I end up with mu equals mg sine theta divided by mg cosine theta. The mg is on the top and the bottom, so those will cancel. And mu is equal to sine theta divided by cosine theta. You don't need to simplify this further into mu equals tan theta. And the last problem. We have 1 over s sub I plus 1 over s sub o is equal to 1 over f, and we're just solving for s sub naught, or s sub 0. So first, I want to isolate the term, so I'm going to subtract 1 over s sub I from both sides. Rewrite. And now, if I look at my isolate the unknown, again, my unknown is in the denominator, so I need to multiply both sides by the unknown over 1. So, s sub naught over 1. I have to put parentheses around all of this, because it's s sub naught over 1 times the whole thing. These cancel, and so I get 1 equals 1 over f minus 1 over s sub I, all of that times s sub naught. Now, to isolate my unknown, I have to divide both sides by all of this. These will cancel, and I'm going to end up with s sub naught is equal to 1 divided by 1 over f minus 1 over s sub I. And that is my final answer. So now you're going to go ahead and practice solving a bunch of literal equations. Good luck.